the whole point of me going through it. All right, let's get on with the topic today. Today we're going to look at Wi-Fi, first of all. And the next lesson, we're going to look at the layer 3, the networking layer. So this first one is a fairly short one, but we've spent about half an hour on the assessment anyway, so hopefully that balances out. So if we're talking about Wi-Fi, it's not something that's foreign for us. Okay, every one of us, I dare say, would have Wi-Fi at home. Every one of us will have a router, Wi-Fi router or access point at home. In fact, we have a access point right there. It's a Aruba access point. It's an enterprise access point as opposed to a home router access point that you might have. This functions well for what we're doing here at TAFE because this is not a full access point. It's actually only an antenna, if you like to think of it. It's connected back through Ethernet, through the walls, through the things, into a switch, and like I said, it's powered by that. Through the ports. Okay? We don't need a power plug just in that spot. Just install that. We put it where it's optimal for the reception and the coverage, but it's powered through the power of Ethernet. And the good thing about these type of access points, like I said, it's just an antenna. All the configuration is done centrally. So I go to a management device, Aruba management device. If you have an IT prac in A103, Greg teaches the access point, what's that Aruba stuff at the diploma level, and he's got a cabinet, like a metal cabinet. It's all locked up because it's all full of very valuable equipment. And if you tell him to open it up, he'll show you there's access points, there's the controllers. The controllers is what controls these antennas. So when you do the diploma, you'll be configuring all the Wi-Fi in one area. Even though we've got antennas in loads of places around the campus, in one configuration, and then it sends the configuration out to all of the antennas around the place. And then when you have your laptop, you connect to this Wi-Fi. You walk down the hall, go to another classroom. You might be switching to another antenna, but you don't really realize it. You're just sort of going from one antenna to another antenna without losing any connectivity. A bit like your mobile phones. You probably know that there's mobile phone towers all over the place, and they have what's called cells of coverage. That's why in America there's called cell phones, because there's these coverage areas. And as you walk out of one tower's coverage area and into another one, it just switches over without you actually needing to know that. Okay, so that's why you don't experience any outages, really. Yep.
So yeah, like this, when, for example, like we do have two access points.
Yeah.
One here, one just like end up like it, just
down the hole.
In the hole. So.
Yeah.
So when we do have like when we are talking of just for example my Wi-Fi,
yeah.
I have it like just like a name, password,
yeah.
this kind of thing. So when we understand like moving from A to B.
Yeah.
So these two access points.
Yeah.
As well, two different name and two different
yeah.
password. And then you are talking about the connectivity.
Yeah.
Like when I'm just like I carry my phone from here to B.
Yeah.
Like just your Wi-Fi is connected.
Yeah.
How is happening?
Yours is not set up like here. This is only one name, isn't it? You don't see TAFE SA 12600. You have two at home. You're saying you got a Wi-Fi network called A and a Wi-Fi network called B, right?
So
is that correct?
Yeah.
So there are two Wi-Fi networks.
That's right.
So therefore, they're not acting as one. Do you understand?
Yeah.
Okay. Whereas the TAFE SA is set up. If you look at it, I don't know how to. Let me just quickly show you. You don't see 100 million TAFE SA Wi-Fi networks because. Sorry, let me just make this the main thing. You don't see 100 million TAFE SA different networks. You got the TAFE SA BYOD, bring your own device. You got the TAFE SA Wi-Fi network. You don't see hundreds of them because, like I said, they're acting as one. Whereas yours at home is acting like two. That's why it doesn't switch over automatically, does it? Okay. Whereas these ones are all acting as one. Like I said, one controller, one configuration, one Wi-Fi network. So if they're all the same Wi-Fi network, when you walk out of one cell into another cell, they automatically switch over based on the signal strength. At home, you got two different Wi-Fi networks. They're totally independent to each other. Okay, that's what I'm hearing. So therefore, it's like as if this is a different Wi-Fi network to this one. So why would I switch the Wi-Fi network without why would I switch over unless I'm told to switch over? You get me? Okay, so that's the big difference. So you can't compare the two. And like I was saying with the cell phones, you're not connecting from what's it, Vodafone to Telstra to Optus to anything. You're still all Telstra, aren't you? Or all Vodafone, all Optus. So that's the difference. Whereas your situations, they're different networks. All right, let's keep on wrong. You know how I switched the monitor, the main one? So let's actually. Sorry, I changed the main monitor and I just forgot how to change the display monitor for the main slideshow. So bear with me, let me just change it back and then it should fix up my slideshow. All right, better. All right, so today we're going to look at some home network basics. We're going to look at the network technologies in the home, the wireless standards, wireless traffic controls, and how to set up a router. Like I said, this is not going to be anything new for all of you guys. So some network basics. Connecting home devices. So this is more like what you're talking about today, Gollum, for your home. You've got your Wi-Fi router, which if you got it from TPG, might be a TP-Link router. And then you've got your phone line to it, and then you're connected into either through ADSL or NBN. Most people will be on NBN now. And then this is a physical cable. Okay, so this is a copper cable for your phone lines initially, and then eventually fiber optics when you go to the fiber to the node or fiber to the home, whatever your situation might be, which is that backbone fast network. But at home, all your devices, so go on, this is yours, this is your wife's, this is your laptop, this is your wife's iPad, this is your daughter. Do you have a daughter?
I don't.
No, okay. I have one. You got wife. That's okay. Maybe in the future you have a daughter or son, and they have their Nintendo Switch and what's a PlayStation maybe. So they're all connected with Wi-Fi. So obviously we all know the advantage of Wi-Fi. You're not physical cable. I don't have to walk around with this plugged into my headset and being caught up. It's limiting, isn't it? I can just walk around as I like, sit on the lounge, sit at the kitchen table, sit wherever I like, and be still connected. But obviously, like we talked about when we talked about the physical media, there's some downsides as well to Wi-Fi. First of all, it's not full duplex. If you remember with duplex, where you can listen or talk, and when you're full duplex, you can listen and talk at the same time. When you're using Wi-Fi, it's only half duplex. You're either listening or you're talking, because of the fact that this is contention-based media, meaning we're sharing the same shared media, and every Wi-Fi device is trying to compete with everyone else to have a turn at talking. So you're basically using the CSMA CA, so that's carrier sense multiple access collision avoidance. You're basically telling everyone, I want to talk for 20 seconds now, everyone shut up. Type situations. A bit like me here. When I'm about to talk in the lecture, I just tell, hey, settle down for a bit. I'm going to start talking now. It's like, go on, you better stop. No, only joking. No, not like that. Only joking. Okay, so wireless technology is also easy. You don't need to have physical cables. You don't have to have a physical cable installer. You don't have to go buy physical cables. You don't have to have a switch. If you have 20 devices at home, you probably still can connect without having a 20-port switch. Okay. Components are pretty, like these days, everything's Wi-Fi enabled. I can tell you at home, I've got a Ring doorbell. I've got some, CCTV cameras. I've got the Google Home. I've got the Google little speakers around the place. I've got the Chromecast. I've even got the lights. The lights are like Wi-Fi, and you can control with the Google Home whether you turn it on. Because of the Google speakers, you can just tell the Google speakers the lights on, lights off, whatever. And definitely there's game consoles, your laptops, your smart TVs, some fridges even. Okay, everything's becoming connected. Everything's becoming smart. Just think of the way you used to watch TV. I'm not sure any of you guys are old enough, but most people used to watch TV using their TV antenna in the past, which means you had to go and just tune it, right? Tune it, and you change channel. Yeah. If you had to get someone on the roof, or you actually had those rabbit ears antennas out of your TV, so you can actually watch TV. I can't tell you the last time I actually watched TV that way. Okay, what about you guys? What'd you say, Adam?
Like the analog system.
Not the analog system, even with the digital TV, but through the antenna. I can't say the last time I watched TV like that. Because these days, when I watch TV, it's either through streaming, YouTube, Netflix, all those Akayo, all those kind of things, or even if I'm watching like live TV, like the let's say something that's on Channel 9, you can just go to Channel 9 app and watch live TV through that. You know what I mean? So I can tell you now, I've got an antenna, but I can get rid of that antenna without too much change to my life. And that's what I'm saying. Like, things are always changing. And you know what? Everything's going to be connected. I forgot a couple of things: scanners, printers, climate control. Yes, my friend has an air conditioner, which is a smart. He's got a new one, so he can control it, turn it on while he's away. Driving when it's 40-degree day, he's coming from the beach, and just as he's leaving the beach, he can just on his smartphone turn on the aircon, so that by the time he gets home in half an hour, it's nice and cool. So what is in a home router? So basically a home router, its name, it's called a router, but it's also a switch. Okay, so if you look at this, you've got in this case 4 Ethernet ports. So these are the ports that you can just plug your Ethernet cables, like these ones. And therefore your wired connections. What do I have at home for this purpose? I've got my NAS at home. So that's a network attached storage. That's where I store the files important for the family, like my backups and stuff like that. And even NAS is not that useful these days. I used to stream movies from my NAS, but these days no need to. But you can plug those kind of things directly in. Okay. And then you have this WAN port. This is where your internet connection goes in. Usually, in this case, it's a RJ45. You can see it's wide, the same width as these ones. But you could be a phone line, okay? But you've got these antennas, obviously. And we're using wireless uses radio frequencies. Radio frequencies is just another electromagnetic wavelength. Okay, so we got the visible light, like this is trying to show, the Roy G. Biv, which is the different colors of the rainbow. Those are visible. Those are what we can see. Then we've got all these other wavelengths that we can't see. Okay, we've got gamma rays. You've probably seen the movie The Hulk, but that's probably not real. You got X-rays. You've probably been taken X-rays before. And you got the ultraviolet rays, which I think you're supposed to put sunscreen against. You got infrared, which is heat basically. You got radar, which is like I think the thing we associate radars with speed cameras these days. But really, you can detect planes, you can detect things with radar. We've got our TV FM radio. We've got our shortwave CB radios, like the handheld CB radios, and you got AM. And then somewhere in there, in the whole lot, is our 2.4 and 5 gigahertz range, which is what we use for Wi-Fi. Wireless technology uses electromagnetic waves to carry information between devices. And like I said, it includes all of these things. Some frequencies are set aside for public use, like your TV, radio. These are licensed sections of the spectrum incorporated into some consumer products. including Wi-Fi routers found in most homes. So like I said, out of that area, so that's the whole range, the previous screen. Out of that area, we've got two areas, 2.4 and 5 gigahertz. A hertz is a one wave. If you have one wave per second, it's 1 hertz. So giga means what's a kilo, mega, giga? It's a million hertz per second, isn't it? 2.4 million hertz per second, 2.4 million waves per second going through a single point. That's what it means. So 2.4 is actually very crowded, if you don't know. Like Bluetooth, your old wireless phones, and a whole heap of other things like radio control cars and stuff like that, they all use the 2.4 because it's cheap. Cheap antenna, it's a popular one to use. And other technologies can use this as well. But 5 gigahertz is the modern wireless LAN technologies, and each standard is preceded by 802.11. Okay, then you got the A, B, G, N, AC, and obviously the latest, the AX. Okay, so here's some connectors. So these are Ethernet connectors. I'm sure you've seen these all before. It's a Cat5e, and these are coaxial. This is the old networks we were talking about, but probably you've seen something similar to this for your TV antennas. And we got the power line networks, which I said was a terrible way to do networking, but you basically plug your devices through a power plug, and you use the power network to send signals to each other as well as power. Wireless standards, this is probably more what we're talking about. So the standards, the main organizations responsible for these standards are the IEEE. I think we spoke about them before, the International Electronic Engineers, something or other. And the wireless standards for LAN use the 2.4 and the 5 gigahertz frequencies, collectively referred to as Wi-Fi. Another organization is also the Wi-Fi Alliance, which is responsible for testing LAN devices from different manufacturers, and wireless standards are constantly improving. Yeah, when I first started, Wi-Fi was A, B, and G. Now we've got AX. There's always new ones on the horizon. So here we go. Sometimes they're referred to as Wi-Fi 1, 2, 3, 4, 5, 6, etc. They're almost like how they're not the same, but they're like the generations. Okay, you probably heard of your 4G, 5G on your mobile phones. They're referring to the generations as well, but this is the Wi-Fi 1, 2, 3, 4, 5, 6, etc. is the different generations as well. Like I mentioned, right now it's Wi-Fi 6. Okay, and you can see there's a maximum link rate is 600 to 10 gigabits per second, and the frequency they use is 2 and 5. Or the Wi-Fi 6E uses 6. That's on the horizon. So that's right now. This is the one, but in the future this is coming. Okay, and you can see that indoor it's about 30 meters. So in a circle around you. So if I've got the antenna right there, it's 30 meters all around. So from end to end, it's 60 meters. But for outdoor, we can turn up the power. So don't forget, indoor we've got walls, we've got other like cabinets. We've got all these things blocking the signals. That's the thing about Wi-Fi. It goes through most things, but there's some things that make it hard, that sort of blocks it. So anything metal, anything with electric motor is terrible for Wi-Fi. If you have your Wi-Fi next to your fridge, it's terrible because the fridge is a metal box. It's got electric motor, so all those bad things, that shields it from everything else. So you'll see that you might have, if you have the fridge here, you've got the Wi-Fi router here, you might find that people right on this side will get a lot less range than people on this side. And when we go to you go to the diploma, you will do a whole subject on enterprise wireless, and you'll do what's called a site survey, where you map out the coverage of your Wi-Fi networks, and you'll shift the access points, like the antennas that we just spoke about, to optimize your coverage. But if we look at this, And while I've got my thing open, doesn't that sort of answer a bit about this as well? Okay, so keep your mind sharp, so things will come up in answers. All right, so keep on going. So wireless settings, so generally you have what's called a network name, so it's called SSID, okay? But we just call it a Wi-Fi name. So you saw me show you that there's a couple of Wi-Fis around. You probably on your own devices can see various Wi-Fi networks around because they're broadcasting. Okay, the SSID broadcast is enabled, which means it's visible. That makes it easier for your guests or for your family, for anyone to join your network because they can see it, they can join it. But you can turn that off as well so that no one can actually see the SSID. Not that they can't see your network, they can see your network if they want to. It's just that it's not going to pop up in your little networks that's available. You're probably thinking, oh, that sounds like a good way to hide my network. It's only hides it from your regular users. It doesn't hide it from someone who's actually just actually scanning for Wi-Fi networks. Okay, so it's a bit like that. There's a network mode you can put into mixed mode, which basically allows you to use both the 2.4 and 5 gigahertz ranges. And obviously, with the advent of N and obviously now, we can actually use both at the same time, which is one reason why some of the newer Wi-Fi technology is a lot faster. Because like we said, if we only had one lane of traffic, it can only carry so much data, so much cars. But if we have two lanes or multiple lanes, we can carry a lot more, can't we? So when we're using, we can use multiple frequencies, then we can actually increase the speed. You might see some access points, some of the more fancy ones. Let's see if we can find one. Okay, some of these fancy ones. Okay, why are they not showing the fancy ones? Let's. Okay, so something like this. This looks like a spaceship. Okay, $1,300. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 antennas. First of all, you get great coverage, and also you can do what's called channel bonding, which means instead of using one channel, you can use multiple channels. Again, increasing your throughput. But again, that's not something we're going to be worried about here. It's just something you're going to be learning about in the diploma. Wireless traffic controls. So wireless channels, well, just what a good segue, channels. So when you have a 2.4 gigahertz, you're not using the whole of the 2.4 gigahertz. There's actually 2.4, yeah, and there's a little bit more. You know how there's 2.4, but there's 2.406, 2.407, etc. It goes on. It's like decimal points, isn't it? So we can actually get even finer bits of that range. So wireless channels are created by dividing up. So the 2.4, divide that up into smaller chunks. Dividing that up, and each channel is capable of carrying a different conversation. So remember where I just showed you with that giant $1,300 access point with all those antennas there when I talked about channel bonding? That means I can communicate over multiple channels, and so therefore each time I add an extra channel, I can actually increase the amount of bandwidth. Multiple APs can function in close proximity as long as they're using different channels. That just means that they're not overlapping on each other. You don't even want to be adjacent to them. It's just like if we had a highway with just narrow lanes, you know, if you get a big truck or you're sort of not driving properly, you could interfere with each other, couldn't you? But if you had a highway with really wide lanes, you're pretty safe in your own lane. You're not going to be interfering with someone else's driving or impacting them. So if you look at this, channel 1 and channel 6, they're pretty far apart. So there's obviously 1, 2, 3, 4, 5, 6, 7, 5, 1, 2, 3, 4, 5 in between. So that means they're not going to be interfering as much. Some 5. Sorry, question?
You mentioned before that the Wi-Fi limits, let's say, when you said for your voice and audio. Does this fix that?
Sorry, what do you mean by limits?
You mentioned before that
Quality of service?
Yeah.
Yeah. So quality of service is prioritizing those traffic. Okay, that's not necessarily Wi-Fi. That's in switches as well. So that's just identifying a protocol and giving it more priority than other types of protocol. Okay, so this is not to do with that anyway. This is just increases the by having multiple channels. You can just increase the amount of traffic. Doesn't matter what type of traffic. Okay, but if this access point or switch is also capable of quality service, then it gives further priority to those types of protocols. Does that answer your question? Okay. Some 5 gigahertz wireless technology combine multiple channels, like I was saying, and create a single Y channel, and which provides more bandwidth and increased data rate. So that's what I was talking about with the channel bonding. Wireless is as a shared media, like I said, it's a shared media. It uses that CSMA-CA, collision avoidance, carrier sense multiple access collision avoidance. That's where I say I'm going to talk for the next 20 seconds, no one else talk, and everyone avoids having a collision. Collisions occur when people talk at the same time, basically. I'm sure you've had that situation where you both go to talk and then you both stop because you're sort of talking over each other. But in this case, with the CSMA-CA, it creates a reservation on a channel for a specific conversation. It's almost like I request to send, and then everyone replies clear to send, and then I start sending, and we get acknowledgement that I've sent, and then someone else takes a turn. So first, device asks permission from the AP with a request to send. If the channel is available, the AP responds with a clear to send message, and when the conversation is completed, your device sends an acknowledgement and say, I'm done. Someone else can have a go. Setting up a router. First time these days, you don't even need to set up a router, do you? The only thing you probably, when you get an internet plan, they probably give you a router. It's already configured. It's even got the Wi-Fi configured for you and the password. The pre-shared key, should I say? Not the password. The Wi-Fi name, the Wi-Fi pre-shared key. So I know, anyone have Telstra? No? Okay, that's not a bad thing. But if my brother-in-law has Telstra, and they just give them a router, everything's set up. It's just some weird alphanumeric name, and again, the password is some alphanumeric password, which is totally random, which is sort of good as well. But you don't have to do anything; just plug it in and turn it on, and it's ready to go. But if you do want to customize a little bit, you can configure a lot of these things. Many wireless routers designed for the home have automatic setup utility, and you basically just tell it who I'm connected to, and just downloads the sort of uses that default setting. To connect the router using a wired connection, you plug the Ethernet patch cable in to the internet part, and plug your other end to the LAN port of the router. The internet port will connect to the cable modem, to the DSL or the cable modem. After confirming the computer is connected to the router, the link light lights up and working. So that's the little flashy lights. That's a link light. Most routers have a DHCP server, which will give an IP address to the computers connected, and they get an IP address, and then they're ready to go. And the router becomes the gateway, and you're ready to go. So unlike a sort of enterprise router, your router does not actually route. Your router does what's called NAT, Network Address Translation. Remember that? When we spoke about the Wi-Fi, when we talk about the virtual machines, we talk about a NAT network where you have an inside and an outside. Okay? Your home router does the same thing. You have an inside, which is your home. You have a private address. If you remember me talking about private addresses. So if you think about your home network, I bet your home network starts with 10 dot something, or 172.16 dot something, or 192.168 dot something, because they're all the private address ranges at the different classes. So your inside network will be one of those private IP addresses, and obviously the internet, which is the outside, is what we talk about public IP addresses. And your router does a network address translation to translate from the private to the public and back. It's just like an interpreter. Okay, it's translating it as far as the world sees, the internet. So let's say you guys are internet, these guys are the home computers. The internet only sees the router as the one IP address, whereas you guys are all hidden away. You don't exist. And it's only when they communicate back that the router has a mapping that this person has a connection with this user here, and now I send the traffic back to that specific device. So even though it's called a router, it doesn't really route. Unlike what we're talking about here with the Cisco routers, where you have multiple networks, they could all be private IP addresses or could be public IP addresses, and you can route between them. Some design considerations. There are several design considerations that should be made before entering a configuration utility or manually configuring the router. So what should you call the SSID? Okay, whatever you do, don't call it something that's identifiable to yourself. Okay, so for example, if my name is Alex and my surname is Zhao, I wouldn't want to put any of those in my SSID, because everyone basically knows who I am then, first of all. Okay. Second of all, if it's a Netgear router, let's say, you shouldn't call it Netgear something, because that's just telling the baddies, oh, it's a Netgear. So let's look at all the things that possibly is wrong with Netgear, and we can try to use that against it. So it shouldn't be identifiable in any way. So that's why I said my brother-in-law with the random alphanumeric thing, sometimes it's good. It's very hard. It's very, very hard to remember, especially if you got multiple. Everyone has one of those. What type of devices? So the other thing you have to consider is, the other thing you had to consider is what type of devices will be connected to the network. Oh, that's interesting. It's great when you have all brand new devices. You can just use the latest technology. I'll give you a situation. I had to go over to my mother-in-law's place. She has one of these TV boxes that watches Chinese TV, and she streams it. But these TV boxes, even though it's brand new, it's sort of old. It was only capable of A, B, and G networks. But they've just got a new router, which was N. Okay, that's good and can always be backward compatible. But the person who set it up on 5 gigahertz only. Okay, on 5 gigahertz only, which means that everyone else was connecting okay. They're all their iPhones, their iPads, their laptops were all good. They're all working, but the mother-in-law couldn't connect, couldn't watch her TV, and that's her only entertainment. Guess what? Oh, the telephone goes crazy and goes, oh, this is not working. I'm like stressed out and this. And then it turned out that because they chose only 5 gigahertz. So if you know you've got some of these older devices, you have to choose the standard that's common to all. Okay, but at what cost? Okay, if the cost is security, if the cost is performance, if the cost is something that's major to your organization, especially if you're doing this for a business, then maybe the plan is not to go down, but it's to upgrade up. So let's just say that the mother-in-law had this TV box, which is a little bit older, couldn't do the 5 gigahertz. Maybe instead of actually dropping down because we're choosing an older standard, especially if it's security, then maybe we should just upgrade her device. Okay, because if it's security versus functionality, security usually trumps all of that. And guess what? Going back here, question, let's have a look. Task 1, question, something or other. Yeah, question 9 here. You're exactly in that situation. Okay, if you read this, the finance manager has a device, Surface Pro 1, that's not compatible. Okay, what are you going to do? What's the issue? WPA3 is the latest protocol, and it's only available in Wi-Fi 6. It's more secure. What are you going to do? The next thing is on your Wi-Fi router, you can also do what's called a MAC address filtering. So we all know what MAC addresses are. They're basically the hardware addresses, the physical addresses, the IPv6 addresses that's on your network cards, including your Wi-Fi network cards. And when we do a filtering is allowing some things through and not allow others. So what we can do on our routers, or our access point routers, or wireless routers, is we can set up MAC address filtering. I'll give you an example. Again, this family with the son who plays games all the time. They're out of control. They're playing games at 2 a.m. in the morning. It sounds familiar, and it's a school night. So they can't control him. So what could you do? You could just put a MAC address filtering to find out what the MAC address is of his network card, put in a list, and if your router's got a schedule or has functionality, you can actually set a schedule so that 12 p.m. block this MAC address.
It's funny because I did that before.
You did that for yourself, or for yourself?
Yeah.
You're blocking yourself.
No, I'm playing these online games at home before.
Yeah.
And then if it's too many users connecting to the internet, it affects my
performance, right? Everyone's having problems. Oh, I don't have internet, but mine's working. Well, that's a thing when you're.
Basically, I know the MAC address. If someone complains, that's her MAC address. If someone shouts, that's her MAC address.
So you can see that this picture.
Connect to the internet.
You can see this picture. All these other devices. Randolph's computer, Randolph's friend's computer, but his roommate, no connection. Okay, so that's what he's doing. But but MAC address filtering it's not really security. Okay, let's put it simply, it's not really security. Like I showed you last week, I can spoof my MAC address quite easily. So if I was Randall's friend, I'll just change my MAC address, and then his filtering would not work anymore. Okay, so that's what you can do. But I wouldn't call it true security. So that's the end of today's presentation, and I think what we have to do now is work through. If we look at the wireless, there's a let's have a look at this. There's a packet tracer. So again, there's a packet tracer. In packet tracer, there's actually Wi-Fi devices. You can actually go in. It's not a real Wi-Fi, obviously, but you can go in and actually configure the Wi-Fi just as if you were. Let's see if I remember my login. Sorry, guys. Ah, I got in. I remember my login. So if you look at this, you've got a Wi-Fi router. But if I click on this and I look at the GUI, it's pretty much as if you're doing this at home. So if to access your this screen at home, you have to just look at what is your gateway. Go connect to the Wi-Fi router, open up the command prompt, look at the gateway, and then you open up a browser, you put in the IP address of your gateway in there, it will bring up a login screen, and usually the username is admin. And if you haven't changed the password and it's a brand new router, it's probably admin is the password. And then you can get in here and you can configure the DHCP settings. You can see there's the DHCP is turned on. If we can go to, let's go to wireless. This is where we can choose this is the older router, by the way. So you can choose whether it's mixed mode, which is using everything, or you're using just B, G, or N. You can look at the channels. Look at this, channel 1 is 2.412. Remember how I said it goes into the smaller increments? So you can have 10. Actually, you can have 11. I can tell this is a US one, because in Australia we can go up to 14. Okay. In US they have you know how they use the Wi-Fi radio frequencies for various reasons. In US they have different range. So when you use 14, 12, 13, 14, it interferes with their other transmission areas. It's actually illegal in US to use any of those higher ones. But in Europe and Australia, you can. How wide is the channel is automatic. Radio band, we can actually look at standard or wide channel. So when we said, remember we talked about the wide channel is where we're using, instead of the 20 megahertz, and not, it's a big M and not a small m. So if you look at the channels, you can see that if we use wide channels, it just has a bigger coverage. So you're interfering with each less. There's Wi-Fi security. Security mode is disabled, but we can choose the WPA WEP. WEP is terrible if you've never heard of it. That's the one where people cracked it and they can actually capture your key and reuse it to connect to your Wi-Fi network. There's WPA personal, which is what you probably use at home. That's where you use a pre-shared key, and everyone has the same pre-shared key. Whereas we probably use WPA enterprise, which is actually uses then a radius authentication source, which is our Active Directory. That's why all of you have your own individual logins. This is an interesting one. This is the guest network. So this is what I do at home. Obviously, I have certain things which are just on the normal Wi-Fi network. But if a friend comes over, I give them the access to the guest network. So it's annoying. If you only have one network, when your friend comes over, you give them the password for your main network. Do they delete it afterwards? Probably not. So they could just park outside someday and just still access your Wi-Fi network potentially, right? So when you have a guest network, you can actually give them access to the guest network, but on the guest network again, you can do more filtering. Like you have a schedule, you can throttle their connection. You can actually block that from accessing any of your internal devices. Like I wouldn't want my people, just friends, who use my network to actually be able to access my Chromecast. Just imagine they could just play their music on my speakers. That'd be annoying, wouldn't it? Just imagine they're sitting at home at 3 a.m. in the morning and they start playing their music on my speaker in my bedroom. Would be very annoying, wouldn't it? So if we have a guest network where the guests go on, and we have a normal Wi-Fi network where your home computer, your smart home stuff goes on, they won't be able to access it. Okay. There's this MAC address filtering. So this is what we talked about before with Randolph and his friends. So we can actually do a client list, type the MAC address in, or learn it from your friends, and we can look at some of the advanced Wi-Fi settings. Access restriction. We can actually even create some policies. So this is where we can actually, I think Jai, you asked about the different protocols. We can actually block certain protocols. So, for example, on the guest network, I might just add. Oh, sorry, not that. We might just actually block all of these other things, except for HTTP. No, I can't keep on. This is a simulation, obviously. I can block everything except for HTTP, HTTPS, and DNS, and that will just give them web access. Okay. So you can see you can sort of play around with this. Applications in gaming, we can actually do port forwarding. So I'm not sure if any of you guys, probably Randolph will know. So if you have NAT, which means you've got a private network at home and you've got the internet on the internet, you cannot provide a service to the internet. You can't set up a home computer and be a web server to the internet because they could never find you because you've got a private IP address. But your router has a public IP address. So what you can do is do port forwarding, which actually forwards your internal computer's port. Let's say it's a game server. Let's say it's 268 is the port number. And I can actually forward it so that it's actually when a computer on the internet accesses my router's IP address on port 268, it's being redirected to specifically my game server computer at home internally. You can only do that once, one port, one computer. Okay, but every port can be a different computer. So that's what's called PAT, port address translation or port forwarding. So NAT breaks the internet. We'll talk about that next. But basically, there's things like port forwarding to help us do that. There's this quality of service. That's what you were talking about. So quality of service, we can actually add a host with their MAC address, and we can actually give them normal high priority. So Randolph, instead of blocking your friends completely, maybe you can give them a low priority, whereas your PC can be high priority. Okay, if it has it. We can look at the status. Right now it's not connected to anything as you expect, but you can look at your status. You can look at what devices are connected as well. So if we actually, these are connected. So let's get back here. Okay, local area wireless network. That's the MAC address. Okay, DHCP client list. So Randolph finding his friends. Oh, there's these free IP addresses. These are the free MAC addresses. Oh, maybe I'll copy this one. So I'll copy it. And then how do I get out of this? Then I'll go back here into my access restrictions. And then, security. Wireless. Where was it? Here it is. MAC address filtering. Then I put that MAC address in, and then I can filter. There was a couple of other things there that was interesting. I might walk you around it. So there's security. So that MAC address filtering, if you remember, I said was not real security, but we can actually have firewall. I can't enable it unfortunately on this one, but if you at home you can actually create internet filters, web filters, and stuff like that as well, which basically allows and blocks certain connections. So if you are just using your internet for web access, which is HTTP, HTTPS, 480, 443, and probably DNS, probably not even DNS because you're using your router as your DNS server, that's all you can allow. So if your computer's trying to use any other protocol, it's going to be denied, which keeps your computer safer, but also means there's some things that are not going to function. All right, so I think there's enough talking from me.